Welcome to the lecture on computer representation of simulation of single server queuing system. So, in the last lecture we discussed about the single channel queuing system, where we found the QT, BT and delays. All the calculations were done by finding the graphs on the axis, and we tried to find that how these performance measures are computed. Now, we will have an overview, or we will have to see that how in the computer, when we do the simulation, how the things are updated as we move from time to time. So, as we know that the computers basically read whatever is fed to them. So, being a transient case, you have the events occurring at different times. So, there will be initialization initially at time equal to 0, and then the computer has to read the subroutines or routines or programs. So, it will invoke the main program to take the data from the respective subroutines. Based on that, it will update the counters, update the variables list, and then slowly, with respect to the earlier cycles or previous values, it will try to update the statistical counters. So, we will have in this lecture, we will have the snapshots of how the computer proceeds by by every iteration. At every time it will move and it will tell you that how the different values are updated. So, the same problem which we discussed in the last class, that we will see in this case. So, how the computer is going to do the analysis. Now, in the computer, when the computer is there, it will have basically the one is that it will talk about the system, what system is telling. You will have system states which will talk about how many persons are there in the system, how many arrivals are there. So, this way there will be a system. There will have, we will have the clock which will talk about the timings. It will tell that what is the present time, what is the time at which the last event has occurred or present event is occurring. So, what is the present simulation clock time. It will talk about the event list. It will tell that which of the event is most imminent. In the computer you fill, you give the user subroutines, you have the programs by which you feed these values, that when there will be first arrival, when there will be second arrival or so. Now, it will talk on logical basis, it has to decide that which one will be occurring next, and then based on that every time, once it moves from one time to other, the statistical counter is there. So, basically these parameters or performance measures, they are updated one by one. So, we will see that how that is updated. So, what we see in the computer representation, you have basically in normal computers representation, you have one is your system. So, this is your system. Then you have the system state here. Now, in this side you have the computer representation. In the computer representation you have system state. So, you have the system state which will have few parameters, that one is server status. Second is persons in queue. So, it is number in queue. Third will be arrivals. So, that is times of the arrivals, and then you have time of last event. So, this is your system state. Then you will have another portion in which you have the calculation of statistical counters. So, you will have statistical counters, and in the statistical counters you have the delay. So, that is number delayed, then you have total delay, then you have area under QT, and area under BT. So, we have found this QT and BT curve in the previous lecture. So, from there how the computer represents, and you directly get. In this you are having one clock and another is event list. So, in the event list you will have two events basically, one is arrival and another is departure. So, this is how, now this is your system which will, so that talks about what the situation is. It will talk about the event which is occurring, whether there is any arrival or there is departure. So, if there is arrival, it will be arrival at certain time, if there will be departure, it will be departure at certain time, and initially you are initializing the system at time t equal to 0. So, first of all certainly we start with initializing the system at time equal to 0. So, the main program invokes the initialization routine. So, initialization time t equal to 0. At t equal to 0 you have a server, you do not have any customer in the system. So, it means that the server is, so at t equal to 0, since there is no customer, your server is idle, it will be 0. So, that is why there is no person in the queue, there is no arrival, nothing is. So, we have time 0, this is clock time is 0. Now, at time 0 it has to say from the event list, the computer has to read this and then it has to decide what is the next most imminent event. Now, if you look at the data, as we have seen, your first arrival is at 0.4. So, it means the first is only arrival, there cannot be first departure, there can be only first arrival. So, what we see is the next arrival which is scheduled is 0.4. Now, at this time, because in the next iteration, once the computer has to go to next iteration, it has to see that whether it has to take the arrival or departure. So, anyway it cannot afford to take departure. So, initially it is poisoned, the departure is poisoned. So, in the first iteration the time of departure is taken as infinity, very high value. So, basically that poisons it, this is known as poisoning of the departure. There is no person in the system, so there is no delayed, so it will be 0, total delay is 0, there is no other value previous, so it will all be 0. Now, the computer will look to the next time, the next event, it will look for the next event time from the event list. It will see to the event list and it will see the minimum of the 2, and the minimum of the 2, whatever it is either arrival or departure. So, that will be taken as the next event. So, we will go to next case. Now, in this case again we have, this is the system. Now, in this case we are coming to arrival time equal to 0.4. So, you have the server which is represented by the box, and one person has arrived, there is one arrival in the system. So, that will be represented by a circle here. He is coming at 0.4 time. So, it means that in the system in front of the server there is one person who is standing in front of the server. He is coming and he has stood in front of the server to get the service. Now, we are coming to system state. In the system state you have server status. So, as there is a customer in front of the server, so server state becomes busy. So, it will become 1. Then number in queue. Now, number in queue means, as we have already discussed, number in queue means the person, as long as he is not on the service counter, he is in the queue. Once he goes, he is already in the system, but not, he is said to be in the queue. So, it means still number in queue is 0, because he is already at the service counter. The arrivals, times of arrivals is represented by the array of. So, you have some array defined, because you will be having number of customers who will be coming, and they will be grouping themselves. So, you have times of arrival. So, the person who is already there, he is already here, there is no person who has arrived. Had been another arrival, it will come the time here. Time of last event will be again 0.4. Now, we will come to clock. So, clock time is set as 0.4. We are coming to the event list. In the event list, the next arrival, because this arrival we have already taken. So, next arrival is scheduled at the time, inter-arrival time is given as 1.2. So, next arrival is scheduled at 1.6, and the departure, because the first customer has come. So, for him the departure will be 0.4 plus 2, so 2.4. So, his departure will be at 2.4. Now, number delayed. So, this is as one person has come into the system, the number delayed is taken as 1. When this reaches to 6, the simulation stops, that is the stopping condition for the simulation. Total delay he has not experienced any delay, so its value is 0. Area under Qt now area under Qt will be the area under Qt value from the previous time plus number in Q times the time lag between this and this event. So, this is how area under Q is updated every time. Whatever you had the earlier value plus number in Q times the time which has elapsed between this event and the previous event. So, anyway it is 0 plus again it is 0 here. So, it will be again 0. Now, it will be area under Bt, busy time function. Now, area under busy time function, if you look at, it will be the previous value plus whether the server is busy or idle. So, server is, if you look at that, in this case the server is idle. So, it is having 0. So, 0 plus 0 times this time lag. So, it will be 0. So far area under Bt is coming out to be 0. Now, we will go to the third case. So, what we see is from here the computer again sees from the event list of the arrival and the departure, the arrival time is less. So, it will take next event as the arrival. So, in the system it will tell again arrival time is 1.6. So, the system representation will be like this: you have a server, in that you had already a customer with at 0.4 and there will be another customer at 1.6. The system state updatation will be done. In the system state you have server status, it will be 1 because server is now, since in front of the server you have customers. So, server is anyway busy. Then you have number in queue. Number in queue, if we look at, it was 0 here because there is only one person in front of the server who is getting the service. Now, you have 2 customers in front of the server. So, this person is said to be in queue, not in the service. So, that is why your number in queue is coming as 1. Then you have times of arrival. Now, what we see is that this person's arrival time is written here, because once this person moves, this person will come and join the server. So, the person who is in queue, it will talk about the time of their their arrival in the queue, I mean in the system. Then you have the time. So, this is your time of last event again, as it is 1.6. Now, we will come to clock. So, clock time is 1.6 and event list. Now, event list you have two, arrival and departure. What we see is in the earlier case you have already taken further the arrival. So, the next arrival will be, if you look at the next arrival, it will be 2.1. And departure as usual it will be here placed. Now, we will update the statistical counters. So, in the statistical counters, you have number delayed. Number delayed is still 1, there is no second customer who has come into the queue. Second is total delay. Total delay still is 0. Then you have area under QT. And area under BT. So, area under QT is here 0 and here the number of person in queue is 0. So, 0 plus 0 into 1.6 minus 0.4. So, since it is 0 and as well as this is 0, so this will again come as 0. Now, the server was busy. So, busy function value was 1. So, area under BT will increase. Area under BT in the earlier case was 0, but now in this case it was 1. So, it will be 0 plus 1 into this time 1.6 minus 0.4. Okay? So, it will be 1.6 minus 0.4, 1.2 multiplied by 1. So, it will be 1.2. So, under the BT function, because there is server is now busy, so this value will increase. Now, let us see the next. So, the next event is, the next event will be again arrival. As you see, among the event list you have further an arrival. So, there will be further arrival at time 2.1. So, the system looks like this. You have the server, in front of that you had one customer, first customer at 0.4, second customer came at 1.6 and third customer has come at 2.1. Now, we will update the system state. In the system state, server status will certainly be busy, because you have many customers in front of the server. Number in queue, as we see the number in queue is 2 persons. So, it will be 2. Then you have times of arrival. So, what we see is you had 1.6 and then another has come at 2.1. This is just to store the additional arrivals which is occurring, and then the time of the last event is 2.1. Now, we will move to the clock. Clock is at 2.1 time, and from the event list we will see arrival and departure. So, last case was the arrival. So, next arrival is at what time? The next arrival, as it is seen, will be at, as we see, at 3.8. The next arrival which is coming at 3.8. And departure is 2.4. Now, we will update the statistical counters. So, what we see is we got this 3.8 from this figure. You have the fourth customer who is coming at 2.1 plus 1.7 3.8, and anyway departure time from the event list is unchanged. So, you have 2.4. Now, we will update the statistical counters. In that you have number delayed. So, there is no change in the number delay, still it is 1, there is no departure so far. Then you have the total delay, that is 0. Then comes area under QT. Now, area under QT will be now changing. The earlier value was 0 plus, since now there is one customer in the queue and there is time lag of 0.5. As we see, the time is 2.1 and this time is 1.6. So, there is lag of time of 0.5 minutes. So, 0.5 multiplied by 1, so it will be 0.5. Similarly, area under BT, area under BT will be previous value plus it was busy. So, 1 times this minus this times, that is 0.5. So, 1.2 plus 0.5, that is 1.7. So, this way the value is updated as the time progresses. Let us see in the next event what happens. So, we will see here. So, after this state, after time 2.1, what we see is there is of the two event in the event list, the lesser value is 2.4. So, next event will be, so it was earlier 1, 2, 3, 4 and the fifth reading was, now here you have a departure. So, departure time and this time is 2.4. So, after this you will have this snapshot coming. At this time, if you look at, you have the server and the customer which was just in front of the server, it has departed. So, now the customer who has come, whose arrival time was 1.6 and he is followed by a customer who is there in the system whose arrival time was 2.1. In this case again we see that server is busy, then there is number in queue is 1, earlier it was 2, and as there is a departure the number of customer in the queue will be 1. From this also array also one value will decrease. So, this 1.6 arrival time customer is anyway in the service, he is getting service. So, now he will you will have 2.1 here, time of last event is 2.4, clock is 2.4. Now, the departure was the event. So, anyway earlier arrival time will not be changed. Now, the customer who has come at 1.6, now he will have the service and he will depart. So, what will be the next departure? That is to be seen. Now, in this case you have arrival is 3.8 and since it is getting free at 2.4 and it takes 0.7 time to serve. So, the next departure will be at 0.7 time. So, 2.4 is the departure time. Next, if it is a departure, the next departure will be for 0.7 time units and it will be 2.4 plus 0.7. So, it will be 3.1. Next imminent departure will be 3.1. Now, we will update the statistical counters. So, number delayed. Now, number delayed, since there is a departure, the second person will go and join the queue. So, number delayed will be 2. When this will reach to 6, the simulation will stop. Then total delay. Now, what will be the total delay for this customer? So, the person who came at 1.6 and departed at 2.4. So, he has to wait for 0.8 times. So, total delay is 0.8. Then area under QT, the last QT value is 0.5 and number in Q is 1 and number in Q here is 2. So, 0.5 plus 2 into time lag, that is 0.3. So, 0.5 plus 2 into 0.3. So, 0.5 plus 0.6, that is 1.1. And then area under BT will be again 1.7 plus time lag, that is 0.3. So, 2. So, this way you have to continue this till you end. So, this is left upon you to exercise and you can follow the book of famous book for studying this modeling and simulation and book by Law and Kelton. So, you can refer this book to study and you can see that how the problem is solved and you can go up to the end of time equal to 8.6. So, this way you can solve such problems and finally, you will see that you will get area under QT and area under BT as the values which we computed in the earlier or previous example. So, you will see that at that time you will have those values coming at 9.9 and 7.7 or so in these cases, and that is how the computer is doing the simulation. So, you can practice more and more problems by taking the inter arrival times and so and service times and you can get the results. Thank you very much.